So I am Pouya, and this is a joint work with Mahyar, Larry Davis, and Rama Chellappa, and today is 2 days before ECCV deadline. Yeah, you don't need. So yeah, over 2017, the first part of 2017, we were thinking about why do we need to do actually image pyramids to detect small faces, and why do we need to run these deep networks multiple times over the image to get all the small faces. And the main issue is actually with the fact that the resolution of the feature maps that goes to that goes into the RPN part for Faster-RCNN or RFCN has a very low resolution. So basically, they cannot accurately propose boxes for faces that are smaller than 16 by 16 pixels. And in wider face dataset, there are like maybe 20% of images that has one dimension less than 16 pixels. So in object detection literature, there were three solutions that people were using, but it was not fully tested on detecting small objects. So this wider provided a good test bed for this. One is context pooling. The other one is the skip connections, and the final baseline is detecting smaller objects from lower levels that has feature maps that are actually bigger. And we trained three baseline methods for face detection to compare our proposed solution. And we claim that our proposed solution is much neater than these three because they need a lot of design decisions. And yes, so usually I explain these three baselines first, but right now I jump into our proposed solution and then to the other ones. So if we have a Faster-RCNN framework, we don't have this part. It is a VGG16 type of architecture. It can be switched with ResNet or anything else. It has the same issue. And then it goes to region proposal and then the classifier. What we propose is that we want to learn how to magnify these feature maps so that we can detect the smaller faces. So we just put one convolutional transpose layer, which is also called the convolutional layer, into the RPN, and we also put another one before the classifier part. And this is our proposed method. You don't need to have any other more design decisions that the ones that you have for Faster-RCNN network. And this is a sample detection result. You can see the size of the faces that our method can detect. Now, the baselines that we train. This does context pooling, and what it does is that it takes the proposed regions and crops a context region from the final feature map and pass that one also through another classifier. So here there are many design decisions that you need to have on how to fuse context with your original box. The next one is using skip connections. With the skip connections, you take the proposals from your RPN and pool the feature maps from earlier layers, and then you concatenate them together. Then you should decide how you want to normalize them, how you want to, again, fuse all these pooled features from the different layers. And the next one is to have a different branch for smaller faces, which is working on a higher resolution layer. And then, again, here, there are a lot of things. You need to decide which sizes you want to detect from the lower one, and you need to know how you should actually, for more details on the design decision, please come to our poster. These are the comparisons that we did with all of these different architectures and showing our results, which gets very similar number to our ECCV17 paper. And for the code, you can go to the repo after ECCV deadline. It is not there yet.